Hello and welcome to Graphing Quadratic Functions. So in today's lesson, we are going to be going over how to graph quadratic functions in standard form and vertex form. Some of this should be review. Well, it should all be review since it's in Algebra 1. But if you forgot it or you just can't remember it, we are going to review it today. So the first thing I want you to start with is a warm-up. It would be great if you would pause the video and complete these warm-up problems on your own. Hopefully you did. And so for these, what you're going to do is you would plug in 3 for x into the f of x function. Now, I would personally use a calculator. And so when we plug in a variable or plug a value in for a variable, we want to use parentheses. So you should get negative 16 for the next one, for the first one. Then be careful here. We would get negative 4 squared minus 2 times negative 4 plus 5. I, again, would plug that into your calculator to get 29. Here, we got a lot going on. So for a calculator, if you want to do it all at the same time, how you would plug it in is you would put parentheses around this first group, so negative 6 times negative 3 plus 2, plus, and then I'm going to group my g term together, 2 squared minus 2 times 2 plus 5. That should equal 25. Now the last one you can't really plug in because you can't plug in variables on your calculator. And so what we're going to do is, again, we're going to plug in for x n minus 2. So we get negative 6 times n minus 2 plus 2. Now for this type of problem, we can simplify by distributing that negative 6n and then combining like terms to get negative 6n plus 14. So there is our first warm-up. Our next warm-up is just kind of an introduction and a review of what we're going to be seeing today. So first of all, the domain for this function, our x values, is negative infinity to infinity. Our range, the bottom of our graph is negative to infinity, and the top of our graph is 4, because that's our y value. Our x-intercepts, that's where we cross the x-axis. So negative 3 and 1. And our y-intercept, where we cross the y-axis, is 3. Our vertex, that's either going to be our highest or our lowest point. So in this case, it's going to be negative 1, 4, and it is a maximum. And then the last thing, increasing, that is where our graph goes up. So we're increasing from negative infinity to negative 1 because that x value is right there, and we always use parentheses. And then we're going to be decreasing where we go down. So for this problem, we're going to be decreasing from negative 1 to infinity. So hopefully all of that kind of made sense because a lot of it's review. But if not, we'll see a lot of it in our notes in our unit this time. So we got a lot of vocab words. That's just because we're going to need a lot of pieces of information, new and old, to graph. So quadratic function is a function with an equation in standard form where a cannot be 0, because otherwise we don't have an x squared term. A parabola, this is your name for the shape of a quadratic, and it is U-shaped. Standard form and vertex form, I told you we're going to see both of those. What is new is this thing called axis of symmetry. Well, it's kind of new. You've seen it. You should have seen it before. What it is a vertical line that cuts the parabola in half. Our vertex, this is the lowest, a minimum, or the highest, maximum point on the graph. Now, we do identify the minimum maximum as with the y value of the vertex. That's just more logistics. I'm just going to ask you, is the vertex a minimum or a maximum? X-intercepts, these are where the graph crosses the x-axis. It will affect in later lessons. These are also the solutions to the function. So we will be solving quadratics in this unit. Our y-intercept, that is where our graph crosses the y-axis. Domain, this is all of our x values that make up the graph. And this, for domain, for quadratics, it will always be negative infinity to infinity. However, our range, this is our y values that make up the graph. This will change, but there is a cheat code to it. So we talked about a lot of these definitions. These are where everything's going to show up. So your axis of symmetry, it is a vertical line that cuts the graph in half. Your vertex is either going to be a minimum or a maximum. So in this case, this is a minimum. We have our x-intercepts, our y-intercepts, and we can reflect it over. Now these are, this is something else new. We can open upward or open downward. For quadratics, you can sometimes also see it's called concave up and concave down. It just means how are you, basically, where are your arrows pointing? And you can tell that because of the A value. So it's concave up if your A is positive, and it's concave down or opens down if A is negative. And this, for this reason right here, is why you can tell your vertex is either going to be a minimum or a maximum. And those will always work. We don't use always a lot, but in this case, you can. Okay, so what we're going to do is, given the graphs below, we're going to find each of the following. So you saw it on the other page. It's right here. But there is a formula to find our axis of symmetry. And I'll write it right here. So our axis of symmetry is x equals negative b all over 2a. Now, remember, it is an equation. I can spell equation right. Okay, so we're working with this equation. I know it's kind of blurry for you, but hopefully you can see it through the video. So we have x equals negative b all over 2a. So our a value for this problem is 1, and our b value is 4. Now, when we replace a variable, we do want to put parentheses around it so we don't lose track of any negatives. So I get negative 4 over 2, which simplifies to negative 2. And so our axis of symmetry is x equals negative 2 because it is an equation. Now, to find our vertex, we can actually identify it here. So here's that axis of symmetry we just found. Look at that, x equals negative 2. And our vertex lies on that line. So in this case, our vertex is negative 2, negative 1. Now you can find your vertex by plugging in your axis of symmetry into your equation. This is your axis of symmetry. But we'll do that at a later point. Now, again, this is a minimum. And in this case, since I'm asking where, we are going, that would be our y value of our vertex, which is negative 1. Okay. You can pause the video if you want to try the next one on your own, or we can do it together. So here we go. Our next one, again, our axis of symmetry. We have a formula, negative b over 2a. So my a value in this case is negative 1, and b is positive 4. So when I plug these in, I get negative b all over 2a. And so I get negative 4 over negative 2, which is positive 2. And so my axis of symmetry is x equals 2. And we can see that in our graph. Now, we do use, for graphing purposes, a dashed line for our axis of symmetry. And then we can see that our vertex is at the tippy top, and it is 2, 7. And in this case, it is a maximum, and it is at 7. Okay, so that is kind of an introduction into what we're going to do next, which is where we're actually going to be graphing standard form. So standard form, we will be having y equals x squared minus 4x plus 5. So let's start by identifying our a, b, and c values. So a is 1, b is negative 4, and c is negative 5. It's in alphabetical order, which is sometimes nice. So now that we have those identified, we can start by finding our axis of symmetry. So I'm going to have x equals negative b, which is negative 4, all over 2a, which is 1. And so when I simplify this, I get 4 over 2, which will give us 2. Now remember, our axis of symmetry is an equation. And so when I graph this, I'm going to use a dashed line for my axis of symmetry. Now, we need to find our vertex. So what we're going to do is we're going to plug in our axis of symmetry into our vertex because our vertex lies on our axis of symmetry. So we are going to plug in 2 into our equation. Now remember, whenever we replace a variable, we use parentheses around what we're plugging in. And again, you can plug this straight into your calculator to get negative 9. And so our vertex is 2 comma negative 9 because our axis of symmetry is our x value, and then we found our y value. Now, based on our a value, we can tell that it's going to open up, so our vertex then is going to be a minimum. And so let's graph that point, 2, negative 9. Now, let's look at finding our y-intercept. So our y-intercept, we plug in 0 for x and solve. The reason then is because all y-intercepts are of the form 0 comma y. And so we get 0 squared minus 4 times 0 minus 5, which you can hopefully see is negative 5. Now what's really cool is that your y-intercept, since when we plug in 0, our a term goes away and our b term goes away, your y-intercept will just be your c value. So I'm going to plot that point. So I'm at negative, my y-intercept is negative 5. Now we can use our axis of symmetry to reflect it over. So how I got that, I'm 1, 2 away. I'm going to go 1, 2 on the other side. So now we have 3 points. We really only need 5 points. So wait, let me rephrase that. We need 5 points. Need 5 points, okay? So what we're going to do is we're going to use our a value to get more points. So 1, 1, and since our a value is 1, I'm just going to go over 1, up 1, reflect it over. You can use our other one, which is 2 comma 4, 2, 4. Well, if you notice, that is our y-intercept, so it's kind of nice. And so that's what that asterisk is there for, is that sometimes your a value, your y-intercept will be able to be one of your points. And then we're going to connect them together. And so our domain, as always, is negative infinity to infinity, and our range is bracket negative 9 to infinity. Now again, the domain will always be negative infinity to infinity, but your range will always have the y value of the vertex, because your vertex is either going to be your highest or your lowest point. So that is how to graph standard form. Let's go to the next page. Here we go. So what we're going to do is we're going to find the following without graphing. Okay, so here's our first problem. So let's start by finding a, b, and c. So 1, negative 10, and negative 5. The direction of opening is up because our a value is positive. Now our axis of symmetry, x equals negative b all over 2a. We get 10 over 2, which simplifies to 5. So we get x equals 5. Don't forget it's an equation. Now I'm going to take my my equation, and I'm going to plug 5 in. So again, we're going to have 5 squared minus 10 times 5 minus 5. You should get, if you're going to try to plug this in, negative 30. And so our vertex is 5 comma negative 30. Our y-intercept, remember, this is your c value, so it is negative 5. And our domain is negative infinity to infinity, where our range is, because it's concave up, our y value is going to be, our vertex is going to be a minimum, so it's going to go negative 30 to infinity. Okay. Now, let's look at the next problem. So our a value is negative 3, b is 12, and c is 6. Because our a value is negative, we're going to be opening down. Always think of if you're having a negative day, you're down, you're sad. Whereas if you're positive, you're happy, you're up, you're having a happy day. I don't know. Pick a way. There's so many ways you can do it. Okay, so here we go. Axis of symmetry, x equals negative b all over 2a. So we get negative 12 over negative 6, which gives us positive 2. So we get x equals 2. Now we're going to find our vertex. So we're going to do f of 2. And so I will just let you know that it is 18. And so our vertex is 2, 18. Our y-intercept, again, it's just our c value. And so our y-intercept is 6. And our domain, as always, is negative infinity to infinity. But our range, because our graph is opening down, it is our vertex is our highest point, so our range is going to be negative infinity to 18 with the bracket. Again, we're using a bracket because we hit at that point. Okay, so there was some practice. Now let's actually graph it. So many information. It's just a lot of repeat. Here we go. So A is 1, B is negative 6, C is negative 1. It opens up because A is positive. Our axis of symmetry, x equals negative b all over 2a. So we get positive, I don't know what's going on, 6 over 2, which is 3. And so our axis of symmetry is x equals 3. From here, we are going to find f of 3, which, if you want to take me at my word, should be negative 10. So that means our vertex is 3, negative 10. This will be a minimum. So let's graph what we got. Our axis of symmetry is at x equals 3. So this is a vux. And so there's my dashed line for my axis of symmetry. Now I'm plot my vertex, which is 3, negative 10. We can find our y-intercept, which is our c value, which is negative 1. I'm going to reflect it over my axis of symmetry, so I'm 3 away. I'm going to go 3 away on the other side. And then I can use my a value, which in this case is 1, to get more points. So I'm going to go 1, 1, reflect over. We'll go over 2, up 4, reflect over. Now I do end up with more points than the 5 needed, but more points, the more accurate your graph is. So I'm going to connect my points. Make sure it does curve, and then don't forget those arrows. And so our domain, negative infinity to infinity, and our range is going to be bracket the y value of our vertex to infinity. Okay, we're almost there. Our next one, I would suggest maybe trying on your own. That is your choice. But here we go. A is negative 2, so because of that, we're going to open down. B is 8, and C is 1. Our axis of symmetry is x equals, again, negative b all over 2a. I know you might be able to do this in your head. I just caution people, especially with all like the negatives and stuff. Look at that. It took me like 30 seconds just to make sure that I have x equals 2. Now that I have that, I'm going to find my vertex. So I'm going to plug 2 in. We get positive 9, which makes sense because we are going to be concave down, so our vertex should be kind of high. Our y-intercept is 1. Now I'm going to write my domain and range just to kind of like see if we're getting it right. So as always, it's going to be negative infinity to infinity. And our range, because our vertex is in this case going to be a maximum because we're concave down or opening down, that means our range is going to be negative infinity to 9 with a bracket. So let's graph this. So x equals 2. My vertex is 2, 9, so 2, 9. And then my y-intercept is 1. I'm going to reflect it over. And then what I have to do next is my a value is negative 2. So what that means is usually it's 1, 1. It's going to become 1, negative 2. And look at that. I have 5 points without having to do more work. So when I connect them, again, we should make our graph curve. And look at that. Our range does match up. So that's standard form. Okay, so standard form gives you your C value. And you can find your axis of symmetry and your vertex by using that formula, x equals negative b all over 2a. Okay, last form. This should be review. Vertex form comes back from transformations, but it's always good to review because quadratics can be difficult. So, vertex form, you might know, it gives you your vertex. So here we go. Our a value is 3, our h value is negative 2, and our k value is negative 4. Remember, these are always opposites of each other because we're on the inside. So our vertex is h comma k, so it's going to be negative 2 comma negative 4. And again, because our a value is positive, I'm going to skip to number 3, we are opening up. And so what that means is that our vertex is going to be a minimum because we're going to be graphing up. Our vertex is either our highest or our lowest point. Now what's really cool about vertex form is vertex form gives you your axis of symmetry. It is the x value of your vertex. So x equals negative 2. So you can think of it as the opposite value of inside the parentheses, or I like to just write the vertex and then drop that down into my axis of symmetry. So here's our axis of symmetry at x equals negative 2. And then my vertex, negative 2 comma negative 4. We can use our a term to find more points. So our a term is 3. So I'm going to go over 1, up 1, 2, 3. And then I'm going to go, so my other one would be, so I went 1, 3, and then it would be 2, 4. 4 times 3 is 12. So I'm going to go over, oopsies, over 2, up 12, which I think is at 8. And we are looking to see, okay, I think it's the y-intercept. So I'm going to connect my points. We can also find our y-intercept for vertex form. This one just takes a little extra work. We are going to plug in 0 for x and solve. Kind of what we did on the other page, but we just found that there was a shortcut. So I'm going to have 3 times 0 plus 2 squared minus 4, and we do get 8. So you can plug that into your vertex to kind of make sure that you did plot it correctly, or your vertex form. And so domain negative infinity to infinity, and our range is bracket the y value of our vertex, which is negative 4, to infinity. Voila! Okay, last problem. Here we go. So a is negative 2. I'm going to really pause for a moment because what that tells us, graph opens down, which means our vertex is going to be a maximum, okay? My h value is positive 4, and my k value is 3. So what that means is my vertex is 4, 3. That also means my axis of symmetry is x equals 4. I'm going to pause for a moment on my y-intercept, and we can actually find some other pieces. Our domain is always going to be negative infinity to infinity. And since we know that our graph is down, we can say our range is negative infinity to the y value of our vertex, which is 3, with a bracket. What I'm going to do right now is I'm going to plot it to see if maybe, perhaps, my y-intercept, we're lucky enough, just shows up. So here we go, 4, 3. Axis of symmetry. My a value is negative 2, so I'm going to go over 1, down 2. I don't think I'm going to get there enough. So what we're going to do let's see it. F of 0, we're going to plug in 0 for x. And when we do, I'm going to give you a hint, it is a very big number. Well, in this case, actually, it's a very small number. Negative 29. So that is off our graph. And we can kind of see that happening because if we take our perfect squares and then we multiply the y values by our a value, which a is negative 2, that's how we get 1 comma negative 2 and 2 comma negative 8. So I did 1. Now I'm going to go over 2, down 8, which is negative 5. And then I'm going to reflect it over my axis of symmetry, connect my points, and voila. There is our graph. And our range is supported by that. Woohoo! Okay. Ooh, I forgot my arrow. So there is graphing standard and vertex form. For questions, remember, I would really remember x equals negative b all over 2a. That is very important. The last page in your packet, it's just steps. It's verbal steps on how to graph standard and vertex form. There is another form called factored form or intercept form. It comes from standard form. It's just there if you want it. We'll see factors later on in our unit. So, hopefully you had fun.